Today I'll talk about the derivation of Hagen-Poiseuille equation. So we have to take that laminar flow through a horizontal circular pipe, and earlier video I got parabolic velocity profile at a horizontal circular pipe. The velocity profile for laminar flow through a horizontal circular pipe I got in the previous video. Please look into that previous video. So velocity profile UZR means velocity in z direction, that is function of r, means uz actually depend on radius of the pipe. So that is equal to minus 1 by 4 mu dp by dz r square minus small r square. Now if I reorganize, so that will be minus 1 by 4 mu dp dz r square common, then 1 minus r by capital R whole square. So that this velocity profile I got from this previous video. Please look into that. And we also got the maximum velocity at the center of the pipe. If you plug r is equal to 0, you will get umax at the center of the pipe. So that is minus dp dz r square by 4 mu. Now using this equation, we will calculate total discharge. Total discharge through pipe means how much that fluid actually flowing through this circular pipe. So what will be the total discharge through the pipe? To find total discharge Q through the pipe, so that will Q is nothing but integration of small dq. So now here we have to put limit 0 to r, means 0 center line to that pipe wall. So that is 2 pi r uzr by dr. Now we already know the velocity profile uzr is equal to minus dp dz capital R square minus r square by 4 mu. Now plug this uzr. Now that equation becomes q is equal to minus 0 to r 2 pi r dp dz capital R square minus small r square by 4 mu into dr. Now if you segregate the constant term, that we know that dp by dz is constant, so that 2 pi by 4 mu integration of 0 to capital R, so r will be multiplied with capital R square minus small r square into dr. So now again if you multiply, so that will be r square into r, then minus r cube dr. Now if we do the integration, we will get, so here minus pi by 2 mu dp dz r square is the constant term, so that will be come out from this integration, then 0 to r small r dr minus 0 to r cube dr. Now if we do the integration, so 0 to r dr is capital R square by 2, 0 to r cube dr, so capital R 4 to the power 4. Now if you plug all this value here from here to here, so we will get q is equal to minus pi by 2 mu dp dz capital R square into r square by 2 minus r to the power by 4 by 4. So it will be like a minus pi by 2 mu dp dz r to the power 4 by 2 minus r to the power 4 by 4. Now if we simplify, then we will get q is nothing but minus pi by 2 mu dp dz r to the power 4 by 4. Now here q is ultimately that pi r to the power 4 dp dz by 8 mu, so minus will come. Now if we plug r is equal to d by 2, so equation become, if we plug that, so q is equal to minus pi by d to the power 4 by 128 mu dp dz. Now so this is the q is the total discharge or volumetric flow rate. So now if we want to calculate the average velocity will be, so q is nothing but a into v is the average velocity, so area into volume, so v will be q by a. So now we know the q, and a is nothing but pi capital R square, okay, q by pi r square. Now so if we substitute, okay, I will get, okay, so here we'll get that u bar is equal to minus 1 by 8 mu. So here, from here, okay, so from here we'll get 1 minus 1 by 8 mu, or you can plug that, so that will be better. Q is pi by d4, pi by d to the power 4, then 4, okay, 4, then 128 mu by 128 mu dp dz, and divided by pi. Now r will be d by 2 whole square. Now so these two 4 will go up. Okay, so it will be like that. Pi, what will happen? So here it will be better. Okay, fine. Now ultimately you will get okay, fine. So now here, so pi d to the power 4. Okay, now 128 mu now into pi, then d square, and here 4 will be up, and then dp dz. So now this pi will cancel out, so that will be square, d square. Okay, 4. Okay, so what will be? That will be 32. So now it will be minus, so minus will be here, minus 1 by 32 mu dp by dz into d square. So that will be that average velocity is this. Okay, now here that minus, so dp by dz also we can write del p by del z. So minus 1 by 32 mu del p del z d square. Now here minus dp dz is equal to 32 mu v by d square from here. So from here if we just change that dp by dz is equal to this. So now pressure drop unit length is dp by dz. Okay, now if pipe length is L, so what will happen? So minus dp by dz is nothing but we can write minus p2 minus p1 by L. Okay, is equal to 32 mu u bar d square. So now p1 by p2 will be 32 mu u bar L by d square. Now if we calculate the pressure head is nothing but p2 minus p1 by rho g. So now rho g will be both side. So now that will be p2 minus p1 by rho g. So pressure head, okay, or maybe the pressure head loss HF will be 32 mu u bar L by rho g d square. So this is actually called Hagen-Poiseuille equation. That's it. Thank you.